Hi, thank you again for tuning in into Agenda AWANI, because this is, you would have noticed, a special recording session on the sideline of the Big Data World Show Malaysia. And as usual, on the sideline of big conferences like this, we've got great people around that we've managed to capture and bring in, because we want to tap into everything they know about big data, whatever is possible within half an hour. So I'd like, without further ado, to introduce my guest for the day, a very special guest, John Burns, Solution Architect for Asia Pacific for MapR. Thank you so much.
Thanks for inviting me.
Now, if you don't know MapR, you might know other maps, but MapR is very, very crucial. MapR is the name. If you look at big data, and under big data will be Hadoop. That's like if you talk about operating systems and you looked at Microsoft or Android and iOS, stuff like that. Yeah. That's my own analogy. But I'm going to let John tell you through his own words, because I would like him to go back 2 steps and explain to us, please, John, what big data means to you, your company, and what you do, and why you're interested to be in these parts of the world.
Okay. So, you know, big data is one of those questions that everybody has their own answer for. The best answer I ever heard was actually somebody from Google. The way he explained it was, big data is any problem where the size of the data is actually part of the problem. So you've got data that's so massive that traditional techniques and traditional hardware won't process the data. So you have to come up with new techniques, new hardwares, new architectures to actually be able to handle that amount of data. You know, Google was one of the first companies to come into run into that problem. You know, when they wanted to organize the whole web, that's a lot of information, and that can't be done on one computer. It can't be done on 100 computers. It takes thousands of computers all working in parallel to be able to process. So they had to come up with a new architecture to be able to handle the processing of this data. One of the problems that happens is when you have thousands of computers, I can guarantee that every day a computer will have a problem. Yeah. So it has to be very fault tolerant. It has to reroute processing around the errors, around the problems. So that's you know, that's kind of where big data came from. It's a way to distribute computation to the data rather than moving the massive amounts of data to where the computation is, and then be able to analyze it, collect the results in one place, and do that in an environment where computers, hard drives can go down at any given time.
We're looking at statistics at this particular big data world show about, you know, billions of devices, like 70, 80 billions by 2020, stuff like that. So I guess if we have billions of devices, you know, the amount of data that one device would generate, and that's just the human input into it. Then there's the servers that just monitors, logs, and whatever else. So can you please make it simple for laymen like me? You have structured data, unstructured data, semi-structured data, human information. So if I use the big data approach, how would, you know, simple logs on the server be read together with human information? Same time there's web browsing and stuff. How would, in one particular bowl, and you have this varied amount of data, that you can make sense of one another?
Yeah. So to be honest, we're just figuring that out, because we never had this problem before. We never had this opportunity before. So, you know, the other buzzword in this industry is data scientist. And that's the role of a data scientist, is to look at these vast resources of data that we have and actually try to figure out what intelligence, what value we can extract from it. So there's the whole realm of data science, where people are trying to actually answer those problems. And part of that is handled through new computations, new algorithms, extending predictive analytics and machine learning, where the machine can actually look at the data, and by giving examples of what one set of data means, look at another set of data and be able to figure out answers from that. And then the other part is, like I said, you know, to be able to handle this on a very, very massive scale. Okay. Because some of this stuff is not, you know, Google has problems that it might take trillions of bytes of data, you know, petabytes of data. They have to sift through that to be able to extract enough information. So the volume is something that is very important in this.
I guess if we go a bit more specific on the you're a solution architect, so I guess I've got to speak a bit of your language. Hadoop, this is the first day today that I'm saying this thing called Hadoop, but I guess it's very crucial because it enables us to really look at big data, use big data. And if I Google correctly, there's this thing that Hadoop came about because of the open source community who got together and bring that out. And then there's also two key things that I've picked out, that it's distributed processing of large sets of data. That's one.
Exactly.
And secondly is, if I have this problem every day, I have a laptop, but because I do so many things on it, if I were to open one large file, it takes ages. So rather than bringing large sets of data to the application, the application or whatever that I want to open it to comes to the large sets of data. So
exactly.
Please help clarify those two things for us.
Well, actually, in your introduction, you made a very good analogy. Hadoop is the operating system of big data, and I think that's very true. So I'm going to go back in history a little bit. It was Google that started coming up with the systems to handle these massive amounts of data. And Google being an open source friendly sort of company, they're not going to give away the company secrets, but they did publish papers giving a general idea how they accomplished this. And those were replicated by some open source enthusiasts at Yahoo who created Hadoop to replicate what Google was doing. That's a distributed compute framework and distributed storage framework that work together. And that was open sourced, and through the community, it kept being enhanced over the years. It's been around for about 9 years now, since 2005, and a lot of enhancements have come to it. And it's become very, very powerful. And that's kind of become the most popular solution. Like Microsoft Windows is very popular for laptop computers, and iOS is very popular for phones, and Linux is very popular for servers. Hadoop has kind of become the de facto standard as the operating system for big data.
So if I don't have to move large sets of data, and I bring whatever that I need to process onto that data. So in terms of computer logic and stuff, it just put the world upside down, right? From the way it used to be done.
Very, very, very aptly put. So we are turning the world upside down. If you're talking about petabytes of data, I mean, we're talking racks of computers that could fill up a room this size. You don't want to move all that data over a network. It would take a long amount of time. So you spread that over many computers, and you send a computation to each computer, and it runs separately on many chunks of the data. And then that's all pulled together in one result. So I think your analogy there is very good.
David has got to go to the mountain, not the mountain to David,
right?
In a sense.
And the other part of that is we have become so accustomed to one way of doing processing that you write a linear program and that runs on one computer. And I think that was my hardest challenge in actually learning big data, was unlearning everything that I knew.
You had to unlearn.
Yes.
You're the solution architect. My God. So hold
That's
that
how I
thought.
got it. Yeah.
Hold that thought. I have to go for the first commercial break, because in this country sometimes saying the word unlearn, making mistakes, you don't actually know about this, it's a taboo. So I want to break that taboo through you, because it's more palatable.
Sure.
You come from the outside. I'm not saying it. You are saying it. That after this short break. Thank you for still watching a special recording on the sideline of the Big Data World Show Malaysia. And I'm still with John here. And John, you're a solution architect. But when all this start coming down your way, you've got to unlearn stuff?
Yeah. So you get used to programming to a certain model of data and doing things in a very linear fashion. When it comes to big data, everything has to be done in parallel. You're splitting it up over hundreds or thousands of computers. And you have to start changing the way you think. With big data, you're often working with unstructured data. Programmers, for the last 20, 30, 50 years, we've worked very hard to structure our data and create systems that handle structured data. But when you're dealing with terabytes of data, the data often comes in a messy fashion, in an unstructured fashion.
When you say unstructured, does that mean that it's not cataloged into a systematic way where the computer language will easily identify, or how do you mean it?
Yeah, so we can talk about structured data, which is, you think of an Excel spreadsheet. Everything's nicely laid out in rows and columns, and everything fits. Yeah. And then there's semi-structured data, which, data might have labels, like hashtags in tweets or something like that. And then you have unstructured data, which might be a picture. Okay. We can look at that and we can impose a structure on it. We know what it is. We can recognize it. But the computer is just a bunch of bytes. Yeah. And you have to write programs to actually, figure out what that is and identify it.
Programs after programs to do all that.
Right. Yeah. So it might have to go through several steps. One time it'll load the data and then apply some structure to it. The second time it'll process it and then organize it and group it. So typically you'd have to go through several steps. But that can happen very quickly with thousands of computers.
Yes. So if you're doing things upside down and things are going from linear structured before to even include non-structured things, so what kind of approaches that needs to be also new? You mentioned before that now it's got to be handled differently. So what kind of differences does it need for somebody managing all that, for example?
Right. So one of the key things with big data is you often don't have very clearly defined objectives of where you're going to go. Okay. Again, science is starting out with a known system, and then you go through a series of steps, create a hypothesis, and then you come up with something that's unknown, that's a previously unknown theory. And if you look at engineering, it's actually exactly the opposite. But when it comes to application in organizations and business and government, you're starting out, you're not exactly sure what you can accomplish. So there's a little bit of risk taking that's involved. You have to have some faith that the data that you have is going to have some value in it. You have to start exploring it, processing it, and you have to use a more agile method. You step through it iteratively in small steps, hopefully make incremental gains. But it's very hard to lay out the concrete timeline sometimes and define concrete results. So management has to understand that.
Exactly. That's why I'm going to come next. If you're right there smack in the middle as a solution architect, you'll see the other end turn that way, and turn that way, and you see the other end. So sometimes you might not know where exactly you'll end up, but you know the direction you're going. But to convince these people who are comfortably here in their linear thoughts and stuff like that. So what do you say, especially in Asia Pacific, to show, not so much convince, but to make people alert to the fact that, hey, you have this new powerful way of doing things, but what do you promise them? How do you prove it to them?
Yeah. So it's actually getting easier. 2 or 3 years ago, when the whole idea of big data was new, it was actually very hard to convince people to take the risks. But more and more organizations have seen the results that other organizations have had. So they're more likely to put faith into it. And we are getting to the point where there's some best practices that you can follow. So if you do this, you should expect this kind of result. But if you get to this point, you're not seeing anything, maybe it's time to give up and try another tactic. So we're becoming more and more aware of the processes that we have to follow and understand risks, risk points, turn back points.
At this Big Data World Show, it amazed me because there's more than a few presenters, even on the first day, saying, you're lucky that the Malaysian government is looking at this, it's open to this. Yeah. And I would have thought that, because we're not among the first, so there would have been many governments around the world. Then I've heard somebody from big brand, name saying that he's from this big European country. Even his government is not really looking at this. So since you are here in Asia Pacific, where is Malaysia in terms of being open to big data and really adopting and doing something about it?
Yeah, so Malaysia is actually fairly well positioned. So there's a couple things that you actually need to enable big data industry to take root. You have to have educational resources, and Malaysia's done very, very well with that. You have to have an infocom infrastructure, good data communications, data center storage. Again, Malaysia has invested in that for quite a while. And you have to have again, it's somewhat of a risk. The government also has to take a risk investing in it.
Okay.
The countries that have actually, there's countries like the United States where it was all came out of the commercial sector, entrepreneurs, risk takers. Culturally here, I think it's a little bit more conservative.
Yeah.
So the government has stepped in as the risk taker, and they've spent money promoting the programs and investing in training of people in big data technologies. And so in that case, that has helped push the industry forward quite a bit.
So the gate is open, but sometimes, as we know, you cannot make the horse drink the water. You can bring it there.
Yeah.
So if the gate is open, big data is inside there. So I guess maybe for Malaysia, there would be certain public aspects that needs to do this as the role model, case studies, good or best practices first, and then maybe the flood will come in.
Yeah, and that's where government also has an advantage, because governments do have a lot of data. You know, public works,
Yes.
Census information, weather meteorology information, traffic information. All these things are big data problems, and you know, they can make an investment in the industry, start projects. They can, you know, be the gas that primes the engine for these projects by starting projects on their own data, and that builds up a talented workforce. And when other people have projects they want to do, the resources are already there.
Yes, go
I was
ahead.
just going to say, India is a very good example of that. They didn't have much in the way of resources, but they had a lot of educated people.
Okay,
And
cool.
the U.S. was outsourcing a lot of their
Thanks
big
to them,
data
yes.
projects to India. Now India has a very, very strong big data industry there, and it keeps bringing in more and more business. It's a very beneficial cycle, and I think it's smart of the Malaysian government to actually invest in that.
Sometimes, you know, if we were talking about the Wild Wild West, if you had known that the new landscape of America then would be like, you know, the aristocrat would be the new aristocrat would be the landowners, for example. So you don't have to fight, risk your life, and try to own large amount of land. You just offer services that will help cultivate that land. So maybe, you know, we're not there in open source with Hadoop and stuff, but if we know where big data is heading, we might park ourselves to offer new services or good services right in front, not at the beginning.
Yes, but that's always hard.
Okay.
You know, predicting the future is hard.
Yeah.
Maybe there's some big data algorithm that can actually solve that. Anyway.
What about applications?
So,
Because they will be how users,
right.
B2B or B2C, would be using
Right.
this.
And that's actually kind of, I think, one of the bottlenecks right now. You look at when you buy a PC, you've got Windows, which is the operating system, but you can buy Microsoft Word, you can buy, you know, Photoshop, Lightroom, all these applications that you put on and enables you. We're still fairly early on in the big data world, so there aren't many canned applications. You have a Hadoop, which is, you know, again, akin to the operating system that sits on top, and any application has to be custom programmed. And that's one of the things actually that I've started to see just in 2014, where there are companies that are building applications to run on top of Hadoop. And it's something that they can replicate, they can sell over and over again, customer can buy it and instantly be enabled to do certain things.
Okay.
So I think that's going to be a very, very big trend in the next few years.
Okay, cool. I want to explore that a bit further. I have to go for the last break, but once we are back, I ask the same question to all my interviewees here at Big Data World Show. If you had advice, if you have an advice to give to not just the young, but of course mostly would be the young people out there who's looking at big data. I might be in school right now, I might be 17, taking my last year's exam and looking at big data, because I don't want to be an accountant, engineer, or lawyer. I look at big data, I see big opportunities. This is exactly what I want to do, help change the world. But where do I start? What would your advice be? Where do I go? Where would I park myself? Do I park myself to build computer algorithm? Do I go with a few groups of people, partner them, and, you know, come up with the next application? Do I look at specific industries, for example, choose healthcare or choose education, and then link it back to big data? What would your advice be? That we'll get to know after this last break. Again, you're still watching a special recording of Agenda AWANI on the sideline of the second annual Big Data World Show Malaysia. And because of that, great people are here. John Burns is one of them. He's a solution architect with MapR. MapR is a big name when it comes to Hadoop. You'll know big data if you know Hadoop, and that's what we've been discussing. But I guess we've skewed the discussion towards the applications of things that needs to sit on top of the architecture that your company and people like you have helped bring. But if you have advice to give to the young people out there who only now wants to join in, especially towards the application part, where would they start? Which area should they look at, for example? All these things, because you've traveled the whole Asia Pac just to look at this.
Yeah. So you mentioned something earlier about if they're not interested in accounting, if they're not interested in finance, if they're not interested in mechanical engineering. And I think that's the perfect person is somebody that has multiple interests.
Okay.
So big data is actually, it takes several different skills. And that will change. Things will become more specialized. Okay. But right now, people that are in big data, they've got rather eclectic mix of skills. Okay. You have to have some programming skills. You have to be able to know how to write programs. You have to understand computers and data storage and performance. You have to have a very good understanding of math and statistics. Okay. That's probably one of the biggest barriers right now is we focus so much on the technical side, the programming and engineering, and the basic math and sciences have been ignored. Okay. There was a gentleman recently, his name escapes me, he's a very famous person, and his quote was that statisticians will be the sexy industry or the sexy job title of the next decade.
Because of big data.
Because of big data, exactly. And 5 years ago, nobody would have thought a statistician was a sexy job, but now it is.
There you go. Taking maths is sexy now. Oh my God, whoever says that, it's only for those thick glasses people sitting at the back of a room. Actuarial sciences used to be sexy before. They focus forward. But now with big data, there you go, statisticians. But before I go there, but if I want to become an entrepreneur, I might not be good at maths or additional maths, So maybe I want to go more to the business side of things. I'm sure for you in your position, you will always see these opportunities that will be arising. Because the moment you're upside down doing that to things, you're disrupting a lot of the normal ways of doing things. Yes. There'll be new ways of doing things.
Exactly. And there's the technical execution, the actual processing of the data and analysis of the data, but it does take the visionaries, the people that do have vision about what it can do, what it can mean, and what it can change, that are actually going to, play a seminal role in the evolution of big data. And it's those people that have those visions and can see a little bit in the future and see a new possibility of what they can do with data that are actually going to make the huge impact. So you don't have to be a programmer, you don't have to be a statistician. Being a visionary, being able to be passionate about it, learn about it, and just creative in its application will make for a lot of opportunities for entrepreneurs.
If I'm in school right now, I want to consider which university to take and which particular course to study. So if I were to align myself to what we've been discussing, apart from maths, which areas do you think I should look at, for example?
Sure. So, you said math, obvious. Make sure there's some statistics in it. Okay, that's a key component in it. There's some computer programming. Okay, but also it's a multidisciplinary area. You have to be able to understand the industries that you're dealing with, the problems that you're dealing with. So you can't operate in a vacuum and just have theoretical knowledge. So you have to understand the business a little bit.
It's both vertical and lateral.
Yes, and that's one of the hard parts about recruiting people for this, because it does take a rather eclectic mix of skills.
So for Asia Pac, how hard is that to get the right mix of talent with the right mix of knowledge?
It's hard. It's hard anywhere. It's not just Asia Pac.
But that's a good thing, right? Because that's opportunity.
Yeah. But it requires very smart people, but also appeals to smart people because you're not boxed into any one discipline. Okay. You get to exercise in a lot of different disciplines. You get to deal with very interesting, complex problems. So it does tend to draw people in. It's a very, very appealing.
But you do believe this is the game changer? We're closing on this last point.
Yeah.
This is the game changer, and life would never be the same again.
Absolutely, absolutely. We had a revolution with computers.
Mm-hmm.
We had a revolution with networking and the internet. And I think this is the next step in that evolution is big data.
Thank you so much, John.
Well, thanks for having
making
me.
time, sharing all your good perspectives on things of the big data, and send in your own views and opinion to the many things and ways that you can do to get to us: Facebook, Instagram, Twitter, or download the iOS and Android application of AWANI, and you can get to watch shows like this live from your favorite mobile gadget anywhere around the world. Thank you, and we'll see you in another episode very, very soon. Goodbye. Thank you so much.
Thank you for having me.